Hi guys, welcome to 14.1 day 3. We are going to continue to work on our transformations and we're going to add some trig functions to those. So we have tangent today, we also have cosecant, secant, and tangent, cotangent to graph with transformations. Okay, so here we go. First, we are going to do these two warm-up questions. I'd like you to pause your video. I'd like you to try both of these. I'm not going to go through them step by step, but feel free to, if your answer doesn't match mine, to come see me in Google Meets and I can go through the problem with you and I can come up with a couple more practice problems easily. Okay, pause your camera. Okay, I hope that you have something similar. If you don't, please feel free to come find me in Google Meets later today and I can answer any questions that you have. Okay, moving on, let's figure out how to graph tangent. So when I graph tangent, I always like to start with the unit circle. So I'm going to draw my unit circle, find my axis values, and remember that tangent is sine over cosine. So I am going to graph these fractions. So at 0, y over x would give you 0 over 1, which is equal to 0. But at pi over 2, I get 1 over 0. Well, 1 over 0 is undefined. So at pi over 2, I actually get a vertical asymptote. And then as I work around the circle at pi, I'm at 0 over 1, which is equal to 0. And at 3 pi over 2, I get negative 1 over 0, which is undefined. And then all the way around the circle at 2 pi, I get 0 again. Okay. And then I can also go this direction around the unit circle and get a vertical asymptote at negative pi over 2, just so that you can see the graph, a few periods of the graph. So this isn't enough. I don't have any shape from these, so I need to pick more values on the unit circle. So I'm going to pick the easiest one to graph, and I think that's at pi over 4, because at pi over 4, our unit circle values are root 2 over 2 and root 2 over 2, which if you put one over the other, you get 1. So at pi over 4, this function is equal to 1. And at 3 pi over 4, we're at negative 1. You could also think of it as negative pi over 4. We're at root 2 over 2 and negative root 2 over 2, which is going to give you a negative 1. So I'm at positive 1 and negative 1. And that should be enough to show we've got a little curve here, and then we follow our asymptotes, and that happens within each period. That's our graph of tangent, okay? The period, as you can see, is a little shorter. It goes from negative pi over 2 to pi over 2, which means the period is pi. The domain is every number except the asymptotes. How do you write that? X can't be pi over 2, but it also can't be 3 pi over 2 and 5 pi over 2. So you would write that by saying k times pi. So whatever k positive or negative, that means that the domain is all numbers except for every pi over 2. And then the range is all reals. Okay, so let's graph that with transformations. 3 tangent, 4 theta. So common misconception is that 3 is the amplitude for all trig functions, but it's not the case for tangent. 3 represents the min, and negative 3 would be 3 is the max and the min, and tangent doesn't have a max or a min, so there's no amplitude. The period now would be pi divided by 4, divided by this number here. So our period now is pi over 4. There is no horizontal shift and there is no vertical shift. So instead of going from 0 to 2 pi for tangent, I'm going to go from negative pi over 2 to positive pi over 2 and drop in this 4 theta in the middle, which means that my function now is going to start at negative pi over 8 and go to positive pi over 8. So I'll type in negative pi over 8, positive pi over 8, and drop in my asymptotes. There's a point at 0 in the middle, and then the 2 points in between, half of pi over 8 will be pi over 16, and negative pi over 16. And then we have this 3 to deal with. So this is going to be 3, and this will be negative 3. So at pi over 16, we're at 3 and negative 3. And then we have our curve. Okay, moving on. Next, again, tangent doesn't have an amplitude. This does have a horizontal shift, but it doesn't look like it has a vertical shift. So let's find the rest of the stuff. The period is going to be pi divided by half, which is 2 pi. And let's figure out the horizontal shift. So again, we set this up with negative pi over 2. Type in our horizontal changes to positive pi over 2. So to solve this one, I have to multiply by half, which would give me negative pi on the left and positive pi on the right, and then I'm going to add pi over 2. So I'm going to get negative pi over 2 and 3 pi over 2. So I'm going to start at negative pi over 2, and I'm going to end at 3 pi over 2. So I'm just going to go by pi over 2's. Pi over 2, pi, 3 pi over 2. Great. So that means that I've got asymptotes at the end of my period. And I think we have enough to graph this. So I'm going to put my 0 point in the middle of the two asymptotes. I'm going to mark half and negative half on my y-axis, and then notice we've got a negative here. So the point on the left is going to be above the midline, or the 0, I suppose, and the point on the right is going to be below. And then I go ahead and I draw my curve. Okay, moving on to secant. So secant and cosecant are very similar, which is nice. You have to remember that secant is the same as 1 over cosine theta, and if you know that, then that's half the battle. So I'm going to actually graph cosine theta here. So I'm going to graph pi over 2, pi, 3 pi over 2, and 2 pi, and mark off 1 and negative 1, and I'm going to graph cosine as a dashed line. 1 period of cosine. Okay, now in our past studies, I'm sure you remember that these are reciprocal values, which means we are going to graph the reciprocal, and we've done this before. Now, we're taking the y values and we're finding reciprocals. So here I've got the reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. So I go ahead and I mark all the places where I'm equal to 1 and negative 1. And then I draw in asymptotes where it crosses the x-axis, because the reciprocal of 0 is undefined. Okay, and then you take, and see if you can follow along here. I'm going to highlight this little area right here, because these are all the y values that are less than 1. If I find the reciprocal of them, so like the reciprocal of, let's say this is half, the reciprocal of half is 2, and the reciprocal of 1/3 is 3, and so on, and I get really close to this asymptote without touching. And then if I do this curve in the middle, all of those numbers are less than 1, and when you find the reciprocal, you end up getting this curve that gets really close to these asymptotes. And there, and if I kept this going, this would look like this, and then I'd have another, I call them cups. It would continue to look like that. Okay, the period for the secant of x, period, that is not spelled right, is 2 pi, just like cosine. The domain is everything except the pi over 2, so we say x can't be pi over 2 plus pi k. And the range, now be careful, it's not all reals. The range is going to be, let me give myself a little bit more room. The range is going to be everything except the numbers between negative 1 to 1. So from negative infinity to negative 1, and then from 1 to positive infinity. Okay, so let's try one with some transformations. So again, secant is one of those, secant doesn't have an amplitude because it doesn't have a max or a min. So you'd say none on the amplitude. This has a period of, we're going to take 2 pi and divide it by 3. So our period is 2 pi over 3. There's no horizontal shift and there's no vertical shift. If we take 0 and put the 3x in the middle, it goes from 0 to 2 pi. Again, you'll see that we're going to start at 0, and we're going to go to 2 pi over 3. Now, I'm going to graph this like I would just graph cosine. So if I would take my period and divide it into fourths, I get 2 pi over 12 or pi over 6. So that's how I'm going to break up my intervals. 3 pi over 6 and 4 pi over 6, which is 2 pi over 3. Good. And then I'm going to graph cosine. That goes from 4 to negative 4, but I'm going to graph it as a dashed line. Okay, now this isn't reciprocal exactly because I know the reciprocal of 4 is 1/4, but you have to just trust that we're doing this in the correct order, and this is just a guide to help you graph. You would graph the parent function, which is this, and then you would vertically stretch it by 4, which would give you this result. So your cups are still made from the tops and the bottoms of these curves. So you get 4 secant 3x. Okay, moving on to cosecant, very similar to sine. So remember, cosecant is, let's look at a color we can read, 1 over sine x. So I'm going to graph sine x, which goes from -1 to 1, starts at 0, 0. And then I'm going to put in points wherever my graph is equal to 1 or -1, and draw in asymptotes where it crosses the x-axis, and then just draw the cups that follow those asymptotes. And that's it. The period is 2 pi. The domain slightly different. X can't be pi plus pi k. So every pi, it can't be pi. And the range, once again, is -∞ to 1, unioned with, to -1, unioned with 1 to positive infinity. Okay, so let's do these transformations. So again, no amplitude for cosecant because it doesn't have a max or a min. None. Ugh, can't write anymore. Horizontal, none. Vertical, none. Period. Let's take a peek. So period would be 2 pi divided by pi, which is just 2. So I'm going to mark this off. I'm fairly confident in my intervals. 1 half, 1 3/2, and 2. And then I'm going to mark the top and the bottom of my cups at half and -1/2. And I'm going to go ahead and graph sine, but remember the negative means I'm going to graph sine reflected over the x-axis. So it's going to look like this. And then I'm going to grab another color and go ahead and put in my asymptotes and then draw in the cups for cosecant. And there you have it. Okay. The last one that we're going to graph is cotangent. Once again, we're going to go back to our trusty circle. Cotangent, remember, is cosine over sine. So we're going to get similar results to tangent, except our points and our asymptotes are going to be in different places. So at 1, 0, cosine over sine is going to be 1 over 0. So at 0, we're going to have an asymptote. And then up here at pi over 2, we've got 0 over 1, which would give you 0. That's at pi over 2. And then we're going to have an asymptote at pi. And we're going to have a point at 3 pi over 2. At the bottom of the circle, we'd have 0 over -1, which would give you 0. And we have an asymptote at 2 pi. Okay, now let's find the rest of our curve. I always go to pi over 4 first. Pi over 4, cotangent and tangent both give you the same result. You both get 1. So at pi over 4, I'm going to get 1. So I'm going to put a 1 right here. Okay, and then I'm going to keep going around the circle. I'm going to go over here at 3 pi over 4. At 3 pi over 4, I get root 2 over 2 a negative root 2 over 2 comma positive root 2 over 2. So I get a negative 1 at 3 pi over 4. So it looks like tangent, but a reflection of it. There's cotangent, okay? So it has a period, just like tangent, of pi. They're the only two trig functions that have a period of pi. And then they have a domain. The x can't be pi plus pi k. It can't be any pi, including 0. And the range is all real numbers. Okay, so let's do one with some transformations. Once again, there's no amplitude. There's not a horizontal shift in this problem, and there's not a vertical shift. That doesn't even look like none. So let's go ahead and figure out the period. Period for cotangent is pi. I'm going to divide by pi over 2, and I end up getting 2. Okay, and then I'm going to, remember, if you take a look at our parent function, it starts at 0 and ends at pi. So let's go ahead and go from 0 and put in the pi over 2 x and send it to pi, multiply by 2 over pi, and you probably can already see the result. We're going to end up going from 0 to 2. Feel confident that I can break that up. So let's go half, 1, 3 halves, and 2. I'm going to go ahead and mark my first points on my cotangent as 40 and negative 40. Put in my asymptotes at the beginning and the end of the period. Put a point here at 1. And then remember your parent function, what it looks like. We're going to take that shape. Our first point between the beginning of our period and the midline is going to be at half 40, and then at 3 halves, negative 40, and we'll get our curve from that. Okay, that's all 6 trig functions. Your homework is to do, I think you have 10 problems to do. So you've got a little bit of everything in these slides. They're all required. Please feel free if you have any questions, come see me. We didn't do any application problems. This is your last one in this video, but I think that you can do it. When we're looking for initial population, you're looking for when t equals 0. What's the largest and the smallest populations? Well, if it's a sine wave, that means how high does it go above the midline and how low does it go? And then when does the population first reach 4,000 butterflies? There is a graph and a function here. You don't need to use those to answer those questions. Good luck, and come find me in Google Meets if you have any questions. See you soon.